let's see what is there in the measure phase flow. So primarily 6 activities or in the measure phase. One is detailed process mapping, and uh, you would use process map. There are various kind of process maps to do process mapping. We'll look at a couple of them. Then you have performance standard. So performance standard is where you would do the baselining. We have covered it a bit during the define phase. So you define what is CDQ, what is the target, what is the specification limit, what is the unit opportunity, defect definition, OPD is opportunity for defect. So everything we would define it in the project plan itself. And then we would put together a data collection plan. In data, we look at how we check normality of the data. You remember we talked about normality. Normal distribution, it's a kind of a distribution wherein there is no high or no too high or too low values which are impacting on the mean, right? And then we would get into some analytics and get into Minitab and see what are the run charts. And then we would do MSA, measurement system analysis, very important topic. A bit tricky one, and we would need Minitab to do gauge RNR exercise. So we will talk about MSA when we get there, and then we will do baselining of the process. What is the current capability of the process in terms of sigma level? How do we calculate sigma level? What are the various data types? We will cover all that, and I do intend to cover all this today itself.
Okay.
Okay, moving on further, process mapping. So let me just ask you, have you prepared any process maps in the past?
I've done a lot of flow charts and that kind of thing, but I don't know if it would be the same as what we're calling process maps. Right.
So yes, process map is flow chart itself. It's a step-by-step event operation, which you present in the graphical form. So in the measure phase, the process maps are a bit detailed, just an expansion of the slide that we saw earlier. At number 1, what we think the process is. Number 2, what it actually is. It's a far bigger than what we think it is, and what we wish it would be. It would be very simple and very easy to interpret. Right? This is the ideal scenario. Number 3, and we always strive to get there. And why process map? Again, no brainer. See, I'll tell you, process map, Scott, is one of the most effective way of process mapping. Rather, is one of the most effective way of doing an improvement. So, we've done a lot of consulting assignments for various organizations based in India, in US, in Europe, and one common tool that we have used everywhere is process mapping. Sometimes the entire assignment gets completed when we map the process successfully. So it is such a great tool that if you map it quite effectively and efficiently, you would be able to identify the gaps in the process, and there itself you would be able to improve the process. And remember, you can never map a process in your head. It always has to go on a board or on a piece of paper. Right, so anybody tells you I know the process in and out, it's all there in my head, it can never happen. Right, so process mapping is such an effective tool and very simple tool as well. So all you need to do is get a few people together in a room, ask them to explain the process to you, and you map the process in front of them step by step, each and every step. And there are various kind of process maps. You have a level 1, level 2, it goes till level 7. Level 7 is a keystroke process map, wherein even if you move your mouse, click on a particular button, that will also get captured in a process map. Level 1 is a SIPOC that we saw in the define phase. Okay, some of the symbols that we use in process map. So any process step is in a rectangular box. And then any decision is where the answer is only yes and no.
Mm-hmm.
You have a symbol for that. Then the start and the end button or stop button
Mm-hmm.
comes like this. Any step where you have data would come like this. Any delay in the process, any manual process, and any manual input. Again, there is no hard and fast. You can again customize process mapping, but these are generally the symbols that you should use while doing the process mapping. But then again, you can customize it as per your own need. There are rather two kind of process map. One is cross-functional process map, and the other one is uni-functional process map. Have you ever had a chance of working on Visio, MS Visio?
Yeah. Yes, I have used Visio.
Right. So Visio is a tool that we generally use for process mapping. It has all the symbols.
Mm-hmm.
If you look at it, it will give you some predefined process map. You can create the cross-functional process maps as well when your process is touching more than one department, more than one functional area. That point of time, you can create the cross-functional process map when it is, and then you can create the unifunctional process map, which is a simple flow diagram without specifying what all function, without having a segregated space for functions or department. Okay, so I'm not covering it in detail, but then it's a simple tool. Yet
Mm-hmm.
again, to re-emphasize, it is very effective as well for any kind of process improvement. So what we say in Six Sigma is that there are two kind of approach that you have in terms of improvement. One is a process door, and other one is a data door. So data door is where we found out what is the measure of centering, and then the variation, and then we look at all the factors and statistically try to validate whether these factors are significantly impacting on the project Y or not. And then there is a process door, and process map is a way to find out, or rather I would say a process map is a way or technique to open that process door. So through that you would be able to identify the redundancies, the repeated steps in the process, the loops in the process. So all these are the areas that you should be able to look at once you're able to map a process. So if we do get a time tomorrow, I will show you some of the maps that we have created in some of the assignments, so that you get the hang of it. Okay,
Wonderful.
then we have a data collection. Data collection is Six Sigma is statistical technique. So if we don't have a data, we would not be able to do a Six Sigma project. So it is very important for us to collect the historical data on the performance, all the related conditions, on the project Y or on the various axes which might be impacting on the project Y. So in the measure phase, we would primarily collect data on the project Y because we want to see what does the data look like, and whether data is telling us what we think the problem is or not. So for example, you initiate a project thinking that my one of the process step is a challenge. So for example, so in the past I was doing one of the assignment with an organization. It was more on a project management. So project management, there is a phase called requirement gathering. So that's an initial phase wherein you gather the requirement that the customer has given you, and basis that you formulate your project plan and you complete the project. So initially when we were called there, they told us, there's a huge problem with the requirement gathering, requirement customer keep on changing the requirement, team is not able to manage the requirement and all that stuff. And because of that, we are getting so many defects. All the defects are pertaining to requirement. If the requirement process is streamlined, we would be able to reduce the defect rate. Hence, we would be able to reduce a lot of, save a lot of cost and effort. So we initiated the project, and the first thing that we did is we started gathering the data on the defect related to requirement. And when we collected the data and when we analyzed the data, what we found out that requirement gathering is only contributing to somewhere about 9 to 10% of defect. Rest, there are two other factors which are contributing to almost 80% of the defects. So that is when we went back to the client and we told the client that, okay, you are saying requirement is a problem, but what we see and what data is telling us is this, right? So many a time what we perceive and what we perceive something to be a problem is not actually a problem. And as a Six Sigma professional, we should never rely on the gut feel. We should always rely on what data is telling us. So we should always collect the data, look at the data, interpret, analyze the data, and basis that take any decision. Sorry. Some time to clear my throat.
No problem.
Okay. So this is a data collection format. This again is one of the format you can customize it as well. It's a so it lists down the performance metric. What is the operational definition of performance metric that you're trying to define? So for example, in your project, you've done average handling time. How do you calculate average handling time would come here. What is the source where you have picked up the data? Is there any data sheet? If yes, what is the data sheet? What is the sample that you have taken to collect the data? Who will collect the data? Where will the data be collected? Where will it be stored? How will you use that particular data, and how would you display that particular data? Everything should come in data collection plan. There are few fields missing, so you can mention what is the data type that we have. And when we go further in the analyze phase, in there we can actually put all the related condition to project Y. So these are all the factors that you think will impact on the project Y. So for example, you said the whole time or the wrap up time is impacting on the average handling time, right? So we need to collect data on the average handling time and then thereafter do analysis, analyze average handling time versus the whole time, and see if there is a significant impact of whole time on the average handling time or not, right? And remember, I keep on saying significant because we only work on factors which are significant. I mean, because in this project we will not be able to change the entire thing. We will not be able to go ahead and change the world. So we only need to work on the vital few causes which are making the maximum impact, right? And that is based on the Pareto principle, 80-20 rule. All right, now